All right, grade 6, this is days 16 and 17. If you look at the schedule, you'll notice that day 16 was a day off. Today is day 17, page 384, numbers 1 through 16. It's one of those green mid-chapter practice tests. I'm going to go through it and take a look at the problems and give you at least some things to think about to help you guide your way through things. Number 1 says, explain what it means for an event to occur at random. And then afterwards, do you notice where it says 9-1 in parentheses? In other words, they want you to look at back in the 9-1. They talk about the concept of something that happens that's random. What do we mean by that? Well, if I flip a coin 100 times, we will get what is known as random results. It's equally likely to occur that that coin's going to land either heads or tails. If you spin a die, or roll a die rather, it's equally likely that either a 1, a 2, a 3, a 4, a 5, or a 6 is going to pop up when that thing stops rolling. The concept of random means that it's very hard to predict necessarily what's going to happen in a circumstance. But take a look at 9-1 for that one. Number 2, state the fundamental counting principle. Remember, the fundamental counting principle is a way of determining how many different outcomes can happen in a situation. And usually it's easier than drawing a tree diagram, isn't it? For example, let's say that a person has 3 different types of meat in their refrigerator, and they have 2 different types of bread, and they have 3 different types of condiments. By condiments, I mean things like ketchup, mustard, and maybe mayonnaise. How many different sandwiches could this person make? Well, the fundamental counting principle says that we can multiply together all of these different situations here, and in this case, we have 18. But they want you to state it, so go to lesson 9-3 and look for the definition of the fundamental counting principle. Number 3, define permutation. Permutation, and afterwards you'll notice it says 9-4 in parentheses. Remember, sometimes we want to figure out the amount of outcomes where the order matters, and sometimes we want to figure out the amount of outcomes where the order does not matter. I'll give you an example of both of those. If you have a running race of 5 people, and there's going to be a prize for first place, say $100, and a prize for second place, say $50, and then after that there's no more prize money, the order in which you finish matters to those racers, right? That would be an example of permutation. Permutation is finding the amount of outcomes where order matters. On the other hand, combination is where the order doesn't matter. Let's say that those 5 runners are in a running race, and it doesn't matter if you win first or second, you get the exact same identical prize, no difference. Well, that's a combination problem for the amount of outcomes, because the order, whether you finish first or second, doesn't matter. Numbers 4, 5, and 6, you might want to think about this little chart I created. Numbers 4, 5, and 6, the directions say 2 number cubes are rolled. Find each probability. When you roll a number cube, you might get a 1 and a 1, or a 1 and a 2, or a 1 and a 3, or a 1 and a 4, or a 1 and a 5, or 1 and a 6, and so on. If you look at this carefully, you'll notice that there's 36 different ways that you can roll 2 die. Or 2 dice, rather. Now, we could have done this with a tree diagram, but that would have been a pretty big tree diagram. You would have had to have, for the first die being rolled, 6 different directions for the lines to go. And then for the second die being rolled, off of each of those 6 different numbers, you'd have to have 6 more numbers going away. But ultimately, you'd end up with a set of outcomes that looks like this. Now, if you look at problem number 4, it says, find the probability of getting a sum of 6. A sum of 6. I'm not going to do that one, but I'll do one similar to that. Find the probability of getting a sum of 7. What would that be? Well, where are 7s? 7s is here, 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 and here. how many of them are there where there's a sum of 7, where the two numbers add up to 7? Well, that would be 6 out of a total of 36, or 1/6. Is that appearing on the board? No, it's not. So these are the ones where you add up the two numbers and you get 7. That's 6 out of 36, or 1/6 for a probability. Hopefully that'll help you with that section. Let's go to 7 and 8. They're asking for tree diagrams. Number 7 says, create a tree diagram and show the sample space for tossing a penny and then tossing a dime. Well, I'm not going to do that one, but I'll do one for this particular situation. What if we toss a penny, then a dime, and then a quarter? What would that look like? Tossing a penny, a dime, and then a quarter. Well, for the penny, it would be heads and tails. For the dime, it would also be heads and tails. And for the quarter, it would also be heads and tails each time. And so what would the sample space look like for a situation like this? It would be heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So notice there's a total of 8 outcomes. And that's the kind of work they're looking for you to do in that situation of problem 7 and 8. 9 and 10, they're asking you to use the fundamental counting principle. Well, earlier in this video, I already did that with you. But let's try it again. Let's try it again. Let's imagine that you are planning on buying a bicycle, and you have 2 different styles of bicycles that you can choose from. And the sizes of the bicycles, there's 3 different sizes, and there's 2 different colors to choose from. Well, fundamental counting principle says you multiply together all of the possible simple outcomes of each circumstance. And so in this case, you'd have 2 times 6 times 2. You'd have 12 different outcomes. How about 11 through 13, where they're talking about those numbers that have exclamation marks after them? Let me give you an example of a problem that's similar to those. We read this as 4 factorial, and we solve it by starting with the 4 and going in descending order down to the number 1, and then multiplying these numbers together, which in this case would give us an answer of 24. But how do we handle the multiplication problem? Let's say, for example, we had 2 factorial times 4 factorial. Well, no big deal. That would be 2 times 1 times 4 times 3 times 2 times 1. And in this case, it would be 24 times 2, or in this case, an answer of 48. Bottom of the page, number 15. I'll give you a clue. That starts off being a fundamental counting principle problem, but then it changes into a probability problem as well. What do I mean by that? Number 15 says Jeffrey has 2 action, 3 comedy, and 4 drama DVDs. If we randomly picks one DVD to watch, what's the probability that it's going to be a comedy? I'm going to do something similar, but I'm going to do it this way with different numbers. I'm going to say 3 action, 3 comedy, and let's say 5 drama. Well, if he randomly picks one DVD to watch, what's the probability that it's going to be a comedy? Well, in this case, I'm going to add these numbers up, and and I get 11. 3 out of the 11 are comedy, and so that is my probability. He has a 3/11ths probability, favorable over all the possible outcomes, to pick a comedy in this circumstance. Problem 16. Molly has 3 windows to display 3 of the 5 best-selling books. How many different displays can she make if she puts 1 book in each window? Well, let's see. She has 3 windows. So here's a window, here's a window, and here's a window. And she's going to display 3 of 5 best-selling books. In other words, 1 book's going to go here, 1 book's going to go here, and 1 book's going to go here. And it says how many different ways can she display them in this particular situation. What if I told you this was a permutation problem? Because we're trying to figure out how many outcomes there could be in this circumstance where you have 5 books, and you're going to randomly put 1 of those 5 books in each of the windows. What if I told you this was the amount of permutations of 5 items taken 3 at a time? Can you solve that? Anyway, hope this helps you. If you get stuck, give me a call. My number is 517-242-3138. Thank you and have a good day.